Hi everyone, today's lesson is on properties of parallel lines. So let's start with three review questions. So when lines are parallel, corresponding angles are sometimes, always, or never congruent. Well, what you're looking at is when you have two lines that are parallel and they're cut by a transversal, corresponding angles could be this angle here and this angle here, and those angles are always congruent. So we're going to say always. When lines are parallel, same side interior angles, so that would be two lines parallel, same side interior, well, if these are the parallel lines, then the interior on the same side, inside, are these two angles. And they're never complementary. Actually, they're supplementary, so you'd say never. When lines are parallel, alternate interior angles are always congruent, because alternate interior angles would look like this. You have an alternate one angle here, alternate side, one angle here, so these are always congruent. The next thing is to find the measure of each numbered angle. So what we're going to do is we're going to look here, and we know that this is 90 degrees, so that means all of these around here are also 90. And it also means that because, well, we can use a couple of things. We know that's 90. We could say alternate interior angles. So we know that the measure of angle 1 is equal to 90 degrees. Also, you could say that this angle here and this angle here are supplementary, because we know that 90 plus 90 is also equal 180, which is the sum of those two angles. Now, we also have two parallel lines right here cut by this transversal. And what that does is it gives us 63 degrees here, 63 degrees here, because those are alternate interior angles. You also have 63 degrees here and 63 degrees here from two different reasons. One being that one and that one, 2 and 63 degrees are corresponding angles. Or you could say that these are vertical angles. Now, to get this angle here or this angle here, you would simply go 180 degrees minus 63 degrees, because remember, this right here is a straight line. Well, you can also think about this angle, this line right here being a straight line. Straight lines add up to be 180 degrees, so you're going to subtract, subtract 7, 1, 1. So you have 117 degrees is going to be angle 3. Also this angle here, angle 117, also that angle, and also this angle. So what we have is the measure of angle, 2 was 63 degrees. We had the measure of angle 3 is equal to 117 degrees. And 63, 63, that's 63, and that's 117 also. So the measure of angle 4 is 117 degrees. Name the angle pair type. So you have angle 5 and angle 3. So you have this one here, this one here. Assuming that these lines are parallel, you'd have to assume that those are parallel. If those lines are parallel, then you would say angle 5 and angle 3 are congruent, and the reason would be those are corresponding angles, and keep in mind they are congruent. Angle 1 and 6, let's see, for this one, let's say 1, here's 1, and angle 6, and if these lines are parallel, then the measure of angle 1 is congruent to the measure of angle 6, because they are on alternate sides. They are outside of the parallel lines, which makes them alternate exterior angles. And alternate exterior angles are congruent. True or false? A transversal only intersects parallel lines. Not true. So that would be false. Let's see, whoops. I'm pretty sure there's an answer behind there. I think. Okay, if two lines are coplanar, then they're parallel. I would say that's false, because you could have, of course, you could have two lines that are parallel and be coplanar. But that doesn't necessarily mean that I can't have another line inside the plane that is coplanar but is not parallel. So I would say that one's also false. If two lines are parallel, then they contain then exactly one plane contains them. Yes, planes lines that are parallel have to be in the same plane, so they have to be coplanar. So that would be a true. And then skew lines are not coplanar. That's also true. Skew lines are in different planes. So we have that. Okay, cool. Corresponding angle postulate basically says that if two parallel lines are cut by a transversal, then the corresponding angles are congruent. And that would mean angle 3 is congruent to angle 2. Alternate interior angle theorem states that if you have two parallel lines cut by a transversal, then the alternate interior angles are congruent. So that would be 1 is congruent to 2. That would be the same angle. Same side interior angle theorem would mean that if two parallel lines are cut by a transversal, then the same side interior angles are supplementary. In this case, they're not congruent. They add up to be 180 degrees. And you would say, we don't have an angle here for that, but we're going to call that 4. So I would say angle 1 and angle 4 are not congruent. You would say the measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. The only way, there is one way where they would be congruent, measure of angle 1, if the measure of angle 1 was equal to the measure of angle 4, that would mean that the transversal was perpendicular, meaning it would look something like this, where you would have perpendicular like that. And in that case, this angle in here, let's even say these angles in here. So this angle here is right, that's right. That would make these two angles congruent. And that would be the only way that the same side interior angles would be congruent, is if that line was perpendicular. Transversal perpendicular theorem. If a transversal is perpendicular to one of the parallel lines, then all of these angles are right angles. So that's right, 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 also right. And then again, this is what I said, that angle, this angle inside here and this angle here would be congruent. A converse of the corresponding angle postulate basically says if two lines are cut by a transversal and the corresponding angles are congruent, then the lines are parallel. So all of the converses are basically saying we have two lines, we don't know if they're parallel, but we do have a transversal. And if the two lines are cut by a transversal and corresponding angles are congruent, meaning if I tell you that that angle and that angle, let's say, are congruent, then only then would that mean this line and this line are parallel. So, and then that's why they call it the converse, because you're doing it the opposite. Instead of saying two lines that are parallel cut by a transversal form corresponding angles that are congruent, you're saying the converse, which is just the backwards. Converse of the alternate interior angles theorem: if two parallel lines are cut by a transversal and alternate interior angles are congruent, then the lines are parallel. Same thing. If I start off with two lines, I'm not sure if they're parallel, but I do know that this angle in here is congruent to that angle here, then these two lines must be parallel. Converse of the same side interior angle theorem basically says if two lines cut by a transversal and same side interior angles are supplementary, meaning this angle here and this angle here add up to be 180 degrees, okay, then this must be parallel to this because the lines are supplementary. Converse of perpendicular theorem: if in a plane two lines perpendicular to the same line would therefore mean that the lines are parallel. So the proof So here's a proof of the alternate interior angle theorem. Remember, alternate interior angle theorem states that angle 1 is going to be congruent to angle 2. But in this case, we're trying to prove that. And so in trying to prove that, you need to understand what would you be given? Well, you're given that two lines are parallel. So you'd probably say that K is parallel to N. So once you say that K and N are parallel, that's given. We're going to try to prove that angle 1 is congruent to angle 2. So we're going to prove that angle 1 is congruent to angle 2. So you need to know where to start with that. So once we start with that, what would you say? What would you need to do first? So at this point, you should pause the video and try to fill in as much as you can, and then start the video again. And of course, remember, the first thing you're going to want to do is say that line K is parallel to line N. And of course, that would be given. So at least you have that. And you also know you're trying to prove that angle 1 is congruent to angle 2. So let's put some angles here. Okay, so pause the video and then let's go on. Go on when you're ready. So hopefully you had some time to work these out. So we have K is parallel to N, that's given, and we're trying to prove that angle 1 is congruent to angle 2. The first thing that I would suggest putting in is that you know that K is parallel to N, and that would be your given, okay? The next thing you came up with was, well, what is exactly that you know? You know that angle 3 is congruent to angle 1 because those are vertical angles. So I would actually state that next. I would say that 1 and 3 are congruent. And the reason being is because those are vertical angles. I also know that I'm trying to prove that 1 is equal to 2. That's ultimately what I'm trying to prove. Now, I do know that 1 is congruent to 3 because they're vertical angles. I also know that 3 and 2 are what we call corresponding angles. And so I can say that 3 and 2 are congruent because those are corresponding angles. And if 3 is equal to 1 and 3 is equal to 2, then by the transitive property, I can say that 1 is congruent to 2. And when you see that 1 is congruent to 2, right here, this has proved the theorem that alternate interior angles are congruent. And what I have here also is just logic, the reasons for my statements. So here's a proof of the same side interior angles theorem. Again, I have two parallel lines that are cut by a transversal. So right off, I know that these lines are parallel. I'm trying to prove that the same side interior angles are supplementary, meaning angle 1 plus angle 4. So I'm trying to prove that the measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. That's what I'm trying to prove. I'm given that line K is parallel to line N. So what you should start off doing is write all your statements and reasons out. Of course, you know that K is parallel to N, and that would be given. And you know, of course, you're trying to prove that the measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. And we're not sure what all the rest of these steps are, but I would pause the video, and then when you're done with your proof and you filled in as much as you can, start the video up again. So what you did was you worked through saying that K is parallel to N. So we know that this line here is parallel to this line here. And you're trying to prove that angle 1 and angle 4 are supplementary angles. You also can write this as this. A measure of angle 1 plus the measure of angle 4 is equal to 180 degrees. The second step that you did was you probably said that angle 1 is congruent to angle 2. Now, we just proved the theorem that stated that alternate interior, if I have two lines that are parallel, alternate interior angles are congruent. So we do know that, so we can state that. So we also know that angle 2 plus angle 4 adds up to be 180 degrees. Now, I would accept either the linear pair theorem or the angle addition postulate, which says angle 2 plus angle 4 is equal to 180 degrees. Thirdly, we know that angle 1 plus 4 is equal to 180 degrees, and that's what I'm trying to prove. I'm going to say it a different way here as my final answer. Angle 1 plus angle 4 is equal to 180 degrees because we're substituting from these two lines here. See, if angle 1 plus angle 2, or excuse me, if angle 1 is equal to angle 2, and here's angle 2. What I did was I took out angle 2 and I supplemented it with angle 1. So here's angle 1, which before it was angle 2. So that's a substitution property. Now, lastly, I would just say angle 1 plus angle 4 are supplementary angles, and that would be my final step. So there wasn't a around the room activity that we did in class. This right here is some of the problems that we went over. So I'm just going to go over those with you. It looks like we have X, Y, and Z. So we actually have three different things to solve for. The first thing is I noticed that I have parallel lines here and here. And I also have parallel lines here and here. And that just shows, those arrows show me that those are parallel. What I need to do is I would say that this angle plus this angle here is equal to 180 degrees, which would give me that X is equal to 60 degrees, because I would say that that would be 180 subtract 120, and that would give me 60 degrees. So here's 60. Because these are parallel, I also know that this angle here is equal to this angle here because those are corresponding angles. So I could also say that 3y is equal to 120 degrees. And if I divide both sides by 3, I'm going to get y is equal to 40 degrees. So I have x equal to 60, I have y is equal to 40. And lastly, I know 60, I know that's also 60 because these are vertical angles. And then I know that this angle here has to be equal to this angle here because those are alternate interior angles. So I can also say that 60 degrees is equal to z plus 50, subtract 50 degrees from both sides, and that's going to give me z is equal to 10 degrees. And box that up. Okay. The second question that we did was, I do notice that these two lines here are parallel. So that's parallel to that. So parallel lines cut by a transversal provide or create alternate interior angles. So I do know that that angle here and this angle here are equal to each other. So x is equal to 2y. However, I have two variables and no values. What I also know is that this is parallel, which means that if this is a right angle, this is also a right angle, which means that x plus 62 degrees is equal to 90. And so if I subtract 62 from both sides, I get x is equal to, borrow, 28 degrees. And so therefore, x would be 28 degrees. That would be 28. So we have x is equal to 28 degrees. You also know that from before, these alternate interior angles, that 28 degrees is equal to 2y, so y equals 14 degrees. Solving for x, y, and z. So one thing is this. You actually know that this is a straight line, and that 80 plus 50 degrees plus, we're not sure, I'm just going to call it, let's call it A, is equal to 180. So 80 and 50 is 130. Well, if I subtract 130 from both sides, okay, I'm going to get A is equal to 50 degrees. So this is also 50 degrees. Okay, keep in mind that's 180. Well, one thing that I do know is that the sum of the angles in a triangle add up to be 180 degrees. I know that 4y plus 5x plus 50 is going to equal 180 degrees. Now, another thing that I should look at, okay, and I'm going to erase this real quick, is that, and put this back in here, we know that's 50. What I want you to look at is this. You've got parallel lines. And in doing this, see these lines right here? This is parallel, okay, to this. So sometimes it's a really good idea to extend your parallel lines. If you notice what I just did, okay, it's hard to draw sideways, but I extended my parallel lines. And in doing that, I noticed that angle Z and this angle here are what we call alternate interior angles. So that actually means that angle Z is equal to 50 degrees. Now, in addition to that, I'm going to erase that. Okay, in addition to that, I also know that this angle, let's see here, or this line right here, and this line right here are also parallel. Okay, which means that I have an alternate interior angle with this angle and with this angle. So you see, sometimes it actually does help to extend those sides. So we also have 5x is equal to 50. So we have x is equal to 10. So we have z is 50, which is right here, because those were alternate interior angles. We have x equal to 50, or excuse me, x equals 10, because that angle equals that. And so if this is 50 and this is 50, then we know this angle has to equal 80. And another way is that those are corresponding angles, but 4y is equal to 80, so y is equal to 20. The next picture, we have x, y, and z. So we know that these two lines here are parallel. So this one, the two blue lines are parallel. And I actually like to extend these. I think it helps because you never know when you need to see if you might see something a little bit differently if you extend them. And then these two lines here are also parallel, this one and then this one. So what I do see is that, let's see, this angle is congruent to this angle. Those are alternate interior angles. It doesn't really help me that much. Y is equal to 2x. Doesn't help right now. However, I also know that this angle here plus this angle here, because those are called same side interior angles, they are supplementary, meaning they add up to be 180. So I could go x plus 10 plus 2x plus 110 degrees is equal to 180. So I have 110 and 10, which makes 120. So let me rewrite this. 3x plus 120 equals 180 degrees. I get 3x is equal to 60. So x is equal to 20. So knowing that x is equal to 20 degrees, I can go back up right here and substitute that in. So y is equal to 2 times x. Well, x is 20. So y is equal to 40. And then we have x and y. Now to find z, where's z? I don't see z. Okay, there's no z. Ding, 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 ding. All right. Solve for x and y. So again, personally, I like to extend my lines. So I'm going to extend this line like this. And then I like to extend it up here like this. Okay. And I know that this angle and this angle right here are congruent because they're alternate interior angles. I also know that angle 70 and angle x are congruent because they're vertical angles. So we know that angle x is equal to 70 degrees. we also know that that's 50 here. And if that's 50, another alternate interior angle would be 50 up here. Now, there's a couple ways I can solve this. I can either go, these three angles in a triangle add up to be 180, because the sum of the angles in a triangle add up to be 180, or I can do this and add these three angles right here, because that makes a straight line. And so if I go 70 plus 50, okay, that's going to be 120 degrees. Let's see. And so therefore, this angle here must be 60. And all you have to do is count, add these up, 0, 8, 1, and that would, y would also be 60. And so y is equal to 60 degrees. Okay. The next question, now this one by far is probably the trickiest problem. But if you listen to what I was saying and actually extend your parallel lines, this might be helpful in that extending these lines right here, this may be one way to see this. If this is 120 degrees, this is an alternate alternate interior angle, which is also 120. And if this is 140, right? So is this angle right here 140, all right? Which basically means this angle here has to be 40 degrees, because that plus that, these two angles here have to be 180. Well, this angle plus this angle are going to be the same because they're alternate interior angles. Let me write that down. 2x minus y is equal to 40. Likewise, we know that this must be 60 because these two add up to be 180, and these angles here also add up to be 180, check, but so do these, all right? And so you also can say that, or I can also say that these are, let's see, alternate interior angles. I'm going to go that route and say 2x plus y is equal to 60 degrees. What I just did was I said 60 and 2x plus y are alternate interior angles. There's so many different ways to do this. You just pick one way. This way that I'm doing this may not be the way that you're doing, that you solve the problem, but that's okay. There's a lot of ways to solve it. What you need to understand is we have an x and a y in both equations, which is good that we have two equations, because if you have two unknowns, you have to have two equations. There's a lot of different ways to solve two equations and two unknowns. Some ways are, let's say, graphing method. You've got what we call elimination method, and sometimes you can have multiplication, with addition and subtraction. You also could solve that by something called Cramer's rule, which is really fun. Or you could solve it by something called augmented matrices, which we haven't learned yet, but is also pretty fun. But this is pretty straightforward, and I'm just going to add these two equations together. And in doing that, I'm going to get 4x, these are going to cancel, is equal to 100. I'm going to divide by both sides by 4, or I'm multiplying by 1/4, and I get x equals 25. So I'm going to go back up to my equation, and it could be either this one or this one, just pick one. And I'm just going to choose the top, which says 2x plus y equals 60, and I'm going to plug in 25 in for x. So I have 2 times 25 plus y equals 60. I have 50 plus y is equal to 60. And then I've got subtract 50. So I have y equals subtract 50. And so y is equal to 10. That's it. So next problem, find the measure of angle C. Now this is kind of interesting right here, because you need to read the question, because a lot of people don't realize that C is actually this entire angle here. What I do want to say is the best way to do this, if you're not sure, again, always remember parallel lines. We're given that A and B are parallel. I would draw in auxiliary line, let's call it T. So I would say draw in auxiliary line T. And what that does is this. Watch what it does, okay? It gives us this line that we just drew in is going to be parallel to A and B, okay? Which then means that we have some alternate interior angles. So I'm actually going to redraw that. Let's try to do a better job at that. So if I draw in auxiliary line T that's parallel to A and B, okay, then we have alternate interior angles. See, that's 80, so is that. And if that's 140, this is 140, which then makes this angle right here 40 because that makes 180. So when I want to know what the measure of angle C is, it's going to be both of these angles together, which is 40 plus 80, which is 120 degrees. That's kind of cool. I like that problem. And that's it. We don't have to know the answers because we just figured out all these problems. I hope this helps you, and I'll see you next time. Thanks.